We have seen regular molecules, ethane and butane. We have seen the stability order. There are molecules with some substitutions. For example, an OH group can be substituted or an NO2 group can be substituted. If groups are substituted, instead of repulsive force, sometimes there might be attractive forces. Sometimes there might be hydrogen bonding. In regular molecules like only butane and all, only repulsive forces between methyl groups, etc. But sometimes attractive force, sometimes hydrogen bonding. So how is this going to decide the stability of the molecules? So to understand that, we have something called judgment of stability. So how do we decide which form exists for more amount of time or which form is more stable? That is decided by these three factors. First, obviously repulsions. How repulsions decide that? We have seen for butane. One more factor is hydrogen bonding. Is hydrogen bonding going to make one of the conformation exist for more amount of time? Conformation is what? Constant rotation. But in between, if there is an attraction in some of the form, that form will stay for longer time. So that means it is increasing the stability of that form. So that is how hydrogen bonding is going to change it. Let us see an example molecule in that way. One molecule that I am discussing is two carbon atoms. This is ethane with two OH groups. What do you think should be the name of the compound?
Eth 1,2 di.
Completed. Correct.
1,2 or diol.
You can call ethane 1,2
Diol.
These are also called as glycols. The other name of these compounds are famously known as glycols. Okay. There are some laxatives as polyethylene glycols, etc., which are laxatives, which means if you consume it, it's more like a fiber, easy, smooth, smooth digestion, smooth bowel movement. So they are polyethylene glycols. Basically, they have diols. So these are two OH groups which have diol. Now, this molecule is nothing but an ethane, but instead of one hydrogen there is OH, instead of on the second carbon atom, instead of other hydrogen there is OH. So that is what I am showing in the molecule here. So instead of hydrogen, the red atom is oxygen. Oxygen is connected to H. Red atom is oxygen. Oxygen is connected to H. Now different Newman projections. Basically, what forms are there? Eclipsed form is possible, which we know. Then staggered form is possible. Now because there is a different group, we can have one more form in between. That form should be called as gauche form. So this is eclipsed form. As you can see, the OH is eclipsing the OH. This is staggered form. You can see the Newman projection. Sorry, this is staggered form. You can see the Newman projection here. OH is below, this OH is above. And you can also see gauche form. This is gauche form. These are the three forms that are possible. Now, normally in the order, most stable one should be staggered because least repulsions. So most stable one is going to be staggered because OH is far away, this OH is far away, repulsions are least. No doubt it should be there. But during the rotation at some point of time, when I get a gauche form, look at this possibility. This is OH. Now, in this OH, oxygen is electronegative atom connected to hydrogen. Oxygen is electronegative atom, hydrogen is connected to it. So partial negative charge on oxygen, partial positive charge on hydrogen. Partial negative charge on oxygen, partial positive charge on hydrogen. So this partial positive charge can attract this hydrogen bond like this. This partial positive charge can attract this. So again a hydrogen bond. So due to this hydrogen bonds, during its rotation somewhere it will stay a second longer. During its rotation somewhere it will stay a second longer. That means most of the time it is existing in what form? Gauche. So the stability order is gauche more than staggered. General expectation, staggered should be the most because of least repulsion. But this time the judgment of stability is based on hydrogen bonding. So hydrogen bonding is increasing the possibility of gauche form to be a little, slightly a second longer than the original value. That is how hydrogen bonding is existing. Any doubt? I am expecting a doubt. Why not stability more in case, more hydrogen bonding in case of eclipsed? That is a doubt. In case of this, repulsion is more dominant. Also, this is not suitable for hydrogen bonding, as you can see. Hydrogen bonding, they should be at a considerable distance also. They recollect hydrogen bonding there. Then hydrogen bonding exists better. In this case, repulsion is dominant, hydrogen bonding is not happening as per the expected value. So that is why in gauche form, best hydrogen bonding is occurring. So that is more stable.